Let's do another exercise regarding theorem of middle point in a triangle. So you can see we have a triangle and this is our instruction. What should we do here? So in this triangle ABC, we have we can see 2 points in the middle, midpoints. ED is in the middle of AB and D is in the middle of AC, and then we draw a line segment here. Then we also see medians. Medians are line segments which connect midpoint with the vertex. And through this we see they drew a line and we can see a quadrilateral. There is a quadrilateral here. EDFG, yeah, or DEFG, this is the quadrilateral. And what we have to do, using midpoint theorem, we need to prove that this quadrilateral is a parallelogram, right? So parallelogram, okay, I'm gonna write it here. We need to prove that this is parallelogram. How to prove it? Using midpoint theorem. We can prove it. We need to find parallel lines. So which lines are parallel? And we look for these triangles. So the first triangle you see here is triangle ABC. So therefore, yeah, we can easily say that ED is parallel to BC. These lines are parallel because that's what midpoint theorem tells you. ED is parallel to BC, but it's not enough yet to tell us that this is parallelogram, because parallelogram has at least one pair of sides parallel, one pair of sides. One pair of sides has to be parallel. So this also FG needs to be parallel to ED, not just ED parallel to BC. So yes, FG is parallel to ED, but how do we know about it? Because you see there is another triangle here, triangle BOC, and as you can see, triangle BOC share the same base, BC. So this triangle has the same base as BC, and triangle ABC has the same base, this one. Therefore, we can say that FG is parallel to BC because we see another midpoint here, that's one, and that one. ED are midpoints of ABC, but FG are midpoints of BC as well. Therefore, they are parallel, and this is already one pair. ED, we can say that ED is parallel to FG. And this is enough proof. This proof is enough to say that this is a parallelogram. We can also say that EF, actually, yeah, we already know that this is parallelogram because one pair of sides meet this requirement that at least one pair of sides are parallel. But also EF and DG, they also parallel. So all of the sides are parallel here to each other. But how do we know that EF and DG are parallel? How do we know about it? This one is also parallel. You need to draw a line. If you draw a line, okay, maybe now I will erase it. There's too much here. So let's draw a line. Line segment. If you draw a line segment from point O to A, you create new triangles. You will create new triangles. Look, so we have triangle ABO, ABO. This is one triangle here. And you have another triangle AOC. And now what do you see? You can see that EF, point EF, it's also midpoint. This is a line segment which is parallel to AO. EF, we can see that EF is parallel to AO according to midpoint theorem. So this line is one side of our parallelogram, of our quadrilateral, is parallel to that side, and the same is with point D and G. They also share, this is this triangle, sides OC and AD have a midpoint line segment here, which is also parallel. So if they are both parallel to AO, they also need to be parallel to each other. So therefore, EF is parallel to AO and DG is parallel to AO. Then EF is parallel to DG. That's it. That is a perfect parallelogram here. We solved the exercise. Hope you find it useful. Thanks for watching.